G'day, my name's James, welcome to the channel, and today's video is all about dimmers. To celebrate the release of the Shelly Dimmer 2, which has come out a few weeks ago, I thought I'd make an episode all about dimmers. So let's check out what we're going to be looking at today. So we're going to be trying all these dimmers out on the oscilloscope to see what sort of output they put out. Now we've got the Shelly Dimmer we're going to be trying on trailing edge and leading edge. So this is not the newest one, unfortunately. I haven't got that one yet, but we're going to be talking about the new Shelly Dimmer 2 and trying out the first version as well. We're also going to be looking at a Z-Wave dimmer and see how that operates. We're going to be looking at the DIY Triac based dimmer that you can get really cheap on AliExpress and from other places. And you can of course hook this up. There's lots of instructions out there on how to do it, hook it up and connect it to Home Assistant. But this is a leading edge dimmer only. We're also going to be looking at this one here from the Clipsal range, the iconic range. Now this dimmer is going to be a little bit different to the others, and it's got a very different output on the oscilloscope. So we're going to check that one out. It's a Bluetooth and a Zigbee dimmer. We're going to have a look at this dimmer briefly because it was a little bit disappointing, and it was probably the loser if we had to pick a loser. And this one here we're going to be checking out is the DALI Master, which is going to control a DALI driver. We're going to see how that operates, and perhaps that would be pretty cool if we could get DALI working with Home Assistant. At the moment there's not really a way to do that, but that's one little device I'm going to show you. And then we've got two of the modules that I've been working on. So this is the latest one just here. So that's got some variations. We've got facility to put a switch, a remote switch, and it goes up to 100%. This one didn't go there. And we've got a very, very prototype-ish dimmer that we're going to try out. It's the first dual channel dimmer that I've constructed and put together for testing purposes, and we had that connected up to Home Assistant with this little Wemos D1 Mini. So we're going to try that one. And this one here we're not going to look at, but that's one that's going to happen later on, and it's going to be part of a multi-channel system that can have as many channels as you want on one controller. So that's what we're going to be checking out today. We've got all our downlights. We've got 16 downlights to try out these dimmers and to see how they go. Let's get started. Okay, so a little bit of information about dimmers. There's two basic types of electronic dimmers. There's trailing edge dimmers and there's leading edge dimmers. Now the leading edge dimmers are the Triac based dimmers usually. Triac dimmers can only do leading edge dimming, they can't do trailing edge dimming. The Triac dimmers are a little bit less complex and lower cost to make. They scale much better, so you often see multi-channel dimmers based on a Triac. I have been working on a universal dimmer which uses two IGBTs, and it can also use two MOSFETs, and I've found that it's actually quite difficult to make it scale or go into multi-channel. You don't get any savings or benefits by having more than one built into the same control board. So that's something I've been working on recently. So that's why you'll see these often available online in multi-channel versions. However, these ones, they can't do trailing edge. Now, it used to be a bit of a problem with electronic transformers if you used a leading edge dimmer, because the cycle doesn't cut in until later in the sine wave. It would draw a lot of current into the capacitors, and it will cause issues with the dimmer, like it would sometimes blow it up and sometimes cause flickering. So that used to be an issue, but more and more drivers and transformers are being designed to work with either trailing edge or dimming edge. So it's not as much of an issue as it used to be. But that's enough about trailing edge and leading edge. Let's have a look at the Shelly dimmer on the oscilloscope, and we'll check out both the trailing edge and leading edge output from that, and then we'll check out this one as well and see how that one works. Now, I haven't got a Shelly Dimmer 2, but basically the main difference is between the Shelly Dimmer 2 and the first generation, which is these ones here, is that you don't have to choose whether you want 2-wire or 3-wire. So I've got 3-wire ones here and they need a neutral, but the new dimmer, if you order it now, it doesn't matter. It will work with either 2-wire or will work with 3-wire. And it will only work with 2-wire if you've got 240 volts, so not if you've got 110 volts. So that's the main difference. Apart from that, they're pretty much the same. And they've got all the same excellent features like minimum brightness, fade rate changing, debouncing the buttons. You can utilize the two inputs here however you want. Super easy to connect to Home Assistant and to other systems as well. I know someone that's got some connected to Home Seer as well, and it was pretty easy to connect them up, and basically packed with features, really easy to set up. So all the same features are there, but it's just that extra bonus. You don't have to choose between the two. Now I've got it set up here with a trailing edge dimmer and a leading edge dimmer. So I've got the oscilloscope connected up to the leading edge dimmer, and you can see here that it's the leading edge that's been cut off to control the power level. So the leading edge on both the upper side and lower side of the sine wave. Now if we adjust the dimmer level here in its interface, we can see the power level change, and it works exactly as it should, works perfectly. And you can see a little bit of the tail from the IGBTs just here and here. You'll see it more with the trailing edge, it'll be more noticeable. And the this can be a problem with older drivers, the leading edge dimmers. These are designed to go with the iron core transformers. With LED drivers, because they're capacitive, it can cause issues because the power turns on here and it can rapidly charge the capacitors really quickly instead of gradually, and it can cause flickering and it can cause damage to the dimmer itself, and it doesn't usually always work. New drivers and new downlights are being designed to work with leading edge dimmers now though. So more and more, if you look at the light, it'll say what dimmer it's designed to work with, and that will sometimes include leading edge now. Although trailing edge is usually better, but usually. But when selecting dimmers though, the main factor as to how well it will work is actually the light fitting. How well the light fitting's been designed, whether it's been designed to accommodate a phase cut dimmer, which is what this is. This is phase cut dimming. So it comes down more to the light than to the dimmer itself when it comes to dimming lights. So that is the leading edge dimmer. We'll stick it up to 100% and you can see we get the full wave coming through. Now, if you use a 2-wire, you wouldn't see the full wave, you'd only get about 95%. So you get like that coming through, because it has to steal some of the power to run the Wi-Fi and the control circuits. Now you'll get that with a rotary dimmer as well. So even a rotary dimmer, a 2-wire rotary will have that and won't go to 100%. But this particular one will go to 100%. I'll just switch over to the other, move my probe. Okay, so we're now looking at the trailing edge, and we can see clearly there that it's the trailing edge that is being cut off to control the power level. And we can see more noticeable is the tail on the IGBT. And MOSFET has a nice clean cut, but the IGBTs have a bit of a tail, which can lead to a little bit of extra losses, but because it's not switching very fast, it doesn't really matter. We can increase our dimmer and we'll see it change just there. And you can see that if it starts at 0, the capacitors and the drivers can charge slowly, and then it cuts off at the end. So that's why this works better with a capacitive lights and LED lights. And that goes up to 100% as well. So yeah, that's the Shelly dimmer. I have found this is the best dimmer. It only has 2 problems. The 2 problems are that it's not certified for use in Australia, which is not saying that there's anything wrong with it, it's just it hasn't been through certification. So shops or outlets can't sell them. So you have to source it yourself if you feel inclined to make that decision. It's also
You can't use this in a roof space. I've tried it out in a roof space, and roof spaces here in Australia are pretty hot, 70 degrees, 80 degrees, and they just cut out. So there's a thermal cutout inside of here, and it won't keep running, it'll stop. But as soon as you remove them from the roof, they will start running again. So it's pretty cool that they're smart enough to protect themselves like that. So if you've got to keep them somewhere cool, like in a switch box, so that they work properly. But other than that, they're awesome. They've got the two little switches, super easy to set up, and they work really well. So I haven't been able to find a better dimmer yet.
Okay, so the next dimmer we have is a Z-Wave dimmer. So this is an Aeotec Z-Wave dimmer, and I believe this is leading edge or trailing edge, but it automatically detects the load and works out which one is best. You can also set it in the parameters, whether you want it to be leading edge or trailing edge. And it has a max load of 1.2 amps, according to this here. And these dimmers do work quite well. I don't particularly like Z-Wave because it can be a bit annoying to set up, and it's obviously low energy, so it has limited contact with the device, which is the reason why it makes it hard to set up. But I guess it's good that it's low energy as well. It's more efficient. At any rate, we've got this one set up just here, and we've got it connected to Home Assistant over here. So we'll just flip over to the where it's controlled, and we can turn it on, and we'll see straight away that that is a trailing edge dimmer that it's found itself set up as. And it looks very similar to the Shelly and my dimmer that I built myself with regards to the trailing edge. It's got IGBTs with the tail just there that you can see. And it's got no problem dimming. There's 1, 2, 8 down lights down there. It's handling that without any problem at all. The only thing is that it doesn't go down as low as the Shelly dimmer. The minimum brightness is not that low. I believe that's as low as it can go in the settings as well. So that's the Aeotec dimmer. It's not a bad choice if you can put up with setting them up. It's small, it has the switches here that you can use to control it. And I believe you can set up the second switches as seen, but it always drives me nuts trying to get that to work in Home Assistant. So it's not really a guaranteed thing. Whereas with the Shelly, it's pretty much a guarantee. You can set up those inputs to do whatever you want in Home Assistant without any problem at all. With Z-Wave devices, it's often a lot more complicated and takes a lot more time. So that's the Aeotec dimmer. Okay, so the next dimmer we've got is this one here. It's one made by Clipsal, and it fits in a switch plate. And it's from the Iconic series. Now this one's a bit different to the others. It's got no Wi-Fi built into it. It has Bluetooth and it has Zigbee. The Zigbee hasn't been activated yet, so you can't actually use the Zigbee, but they say that that is going to be the plan. You can use Zigbee with this dimmer here. It's pretty well made, but it is quite large, and it needs a deep wall box to fit it in. So when you fit it to a plate, the depth is quite deep, and it doesn't fit in a standard wall box. So it needs provision, and it needs a neutral as well. But it does have a remote control switch, so you can control it with a remote switch. So that's another thing that it has. The switch plates allow the light to come through from the mechanism there, so you can set that up to operate however you want it to work. The only thing is that this dimmer may not be necessarily any good, because if they don't provide an API, which they haven't yet, then it's going to be extremely difficult to connect it to other home automation systems like Home Assistant, other than the app that it comes with. But we'll try it out, and it's got an interesting waveform on the oscilloscope. So that there is actually full brightness, and it dims to the center, which is sort of strange. like so. So that's on low power. And that is full power. So it never has the complete sine wave. So I'm not sure whether that's better or not, but it does work very well. Like it dims the lights. I've got them down here. It dims them properly. And a lot of Clipsal's gear does work properly and is well engineered and designed. So I've just connected it up to that just here. So we can turn it off and on. We've got settings. And we can actually activate the switch, the light on the switch. So we can make it always on. So we see that it's got a gentle light that you can activate. Or you can make it so that it's only on when the load is on. Like so. So that's a pretty cool little feature there. Yeah, so that's the Clipsal iconic dimmer range. Okay, so this is the next dimmer we've got, and I've got two of these, and one I've pulled apart so you can have a look inside. And it's a brilliant lighting dimmer, and it's Triac based, which means it's leading edge dimming only. You can see the Triac just here. It's got a 2-year module inside of it, and I was able to successfully 2-year convert both of these pretty easily. And I've tried it with ESP Home and with Tasmoda. It works okay with Tasmoda, except both of these dimmers died for no real reason. The Wi-Fi connectivity has remained, it's still there, like you can connect to it, but it just doesn't dim. So something inside it has died. And I don't especially like these dimmers. They don't seem very practical, they're expensive, and they weren't that great. They did work though, but they're not that great. And it has a RF built into it, so you can get an RF switch to control it. But there is no way to like have a remote switch or anything to control it. So there's no provision for an external push button switch of any sort. So yeah, this is the brilliant dimmer. It's also only got a load rating of 100 watts. So that is the brilliant dimmer, which I actually probably wouldn't recommend. And unfortunately, because both of these have died, I can't show you what they do on the oscilloscope. Let's move on to the next one, and the next one's a Triac based dimmer, and it's just a more DIY, very simple, very basic, and we'll check that one out. That one actually works. Okay, so our next little dimmer we've got is a different one. It's not a production one. It's not made by for general use, I guess you could say, but it's a more of a hobbyist one, and you can get it really cheap. So it's not an expensive dimmer. It's a Triac dimmer, and you've got to connect it up to a microcontroller, and the dimmer puts out a zero crossing signal, and it takes a PWM signal to control the dimming level. And you can just control it with an Arduino or an ESP8266, which is what I'm using just here, just a D1 Mini. And it's hooked up to these pins over here, controlling. And I'm going to actually just control it through the Arduino interface. You can obviously connect it up with MQTT and hook it up to Home Assistant pretty easy if you wanted to do that with this dimmer. And you'll see these dimmers, people make projects out of them, and there's quite a few out there, and you can connect them up in banks so you can have multiple channels. And if your lights work with a leading edge dimmer and you only have a relatively small load, then this is not too bad an option. If obviously they don't come in cases, so there's a bit of work trying to put it all together. It's not quite as simple as the other dimmers we've looked at. However, yeah, we're going to check it out and see what it looks like on the oscilloscope. So I'm just going to plug this into the computer, and we'll connect up the Arduino interface so we can test it. Okay, so we've got our dimmer here connected up, so we won't touch that. And we've got the signal there on the oscilloscope coming through. So this is going to be a leading edge dimmer only. It's not trailing it, you can't change it. So we'll just come up here to the serial monitor and we should be able to change the light level by entering a value in. And we can see there that it's dropped down in the power level, and we can see that it's the leading edge that's dimming down. So that's pretty straightforward. Controlling that dimmer just there. So that is the very basic. I think you can get these modules here for about $3 or $4, and of course the D1 Mini or something small like that is just a couple of bucks. And with that you can put it together. You have to put it in a case of some sort, and you can create your own Wi-Fi dimmer that is easy to connect to Home Assistant with some MQTT. I'll put a link, if you wanted to try out one of these ones, I'll put a link to a pretty cool project that I found on YouTube. That someone's made one of these projects with that connects to MQTT, and it also connects to Blink, the Blink app. So yeah, it's a cool low-cost dimmer that's leading edge. So your downlights or your lighting that you're using would have to suit leading edge dimming. Let's move on to the next one. Alright, so now we're looking at the dimmers that I've designed and put together, and they're Wi-Fi based dimmers, and they're based on an FL5150 IC, which is just down here on each of these boards. They're leading edge or trailing edge dimmers, and I've done a few videos about them before. Now this is the older version, and I've just got this in leading edge mode right now on the oscilloscope, and that's actually at 100%, and it's at the highest it will go, I should say. And it's this little jumper here that can set leading edge or trailing edge. But I've got we're starting with the leading edge dimmer, so you can see that just there, that it's cutting the leading edge. And the reason why it can't get to full power is because this board only has 3.3 volts on it, and in order to get this little IC to go to full power, it needs to have at least 4 volts to get 100%. So it goes up to 95% with 2.5 volts, but then to get to full power it needs 4 volts. So it couldn't be done on this one, so I made a second version, and that's got the provision for 5 volts supply to the DAC, which allows this one here to get to full power at 100%. So we just got the controls for it up here, so we'll just first of all check out the leading edge dimmer, or this one here. We're looking at this one here on the oscilloscope in leading edge mode, and it's got 8 downlights connected to it, like on all the other tests we've done. And you can see it works much the same as the Shelly dimmer in the way it dims and the form on the oscilloscope. So that's this dimmer with leading edge. We'll now swap over to this one here. Okay, now we're going to check out this one here on the oscilloscope, and this is in trailing edge mode. So we've got it turned off at the moment, so we'll just turn it on, and we'll see here that it comes right up to 100%. And that's because it's got the 5 volt power supplying the DAC, and it's able to get the FL5150 chip to go to 100% using that 5 volt supply. So we'll just dim that down a bit and we'll check out the trailing edge. So that's down to 50%. And we see it's got the tail just like the Shelly dimmer had, because it's got IGBTs, that's how the dimming's done. This would actually work with MOSFETs as well. I haven't tried it, but there's no reason why it wouldn't work with appropriately sized MOSFETs as well. And then you wouldn't get this tail here. So although it doesn't really have much effect on the lights, it works fine when it comes to dimming. Yeah, so these are the two, this is the latest version here. Now this version also has another bit of circuitry just here, which I haven't actually tried out yet. And it just allows for a remote switch or push button to be connected to these two terminals here. So you can have this mounted in a switchboard enclosure, and it's designed to go in a little case like this and mount inside a switchboard enclosure. And you can run the wires out to a remote switch, and you can use a push button to control this dimmer, perhaps dim it up and down, and to turn it on and off. So that's another little feature that I've added to this version right here. Now, if you would like to try these dimmers out, first of all, make sure that you have all the appropriate equipment and experience when working with mains voltage, as these can be dangerous and mains voltage is able to kill you instantly. But if you do have all that, if you do have all the knowledge you need and the equipment you need to do it safely and you want to try it out, I'm going to put the files for this in the description down below, so you can get them and make them yourself, or you can buy a kit from the link down below if you would like to just buy one just to try it out. Bearing in mind I'm probably going to make some further modifications and improvements to this board. So you can take your choice. It's there if you wanted to give it a try and see how it works. So that's hasn't really got a name yet, but it's the dimmer that I've built myself. So we'll now move on to the next one, which is a prototype, and it's based on this same IC, and it's a multi-channel board, and it's very prototype, very prototype. But we'll check it out and have a look at it anyway. And there's also, and we'll check out the data sheet for this little module here. So if anyone's trying to use this chip to do any projects, I'll just explain a few things about it that I have discovered by checking out the data sheet for this FL5150. So we'll do that as well afterwards. Okay, one little extra side point before we move on as well is this IC here has a comparator built into it, and it uses these two resistors here to connect to either side of these MOSFETs or IGBTs, and it measures the current flow through the circuit, and it can actually restrict and it will turn off this IC if too much current flows. So that's a way to prevent overcurrent through here. And you can just adjust these resistor sizes, so they both have to be the same, but you can decrease them to reduce the current and increase them to increase the current. So it's another little feature that this little IC has. And if it does trip out, it just needs to be powered off and powered back on again to reset it. All right, we're now looking at the prototype dimmer. It's a dual channel. It's just got two channels side by side. Now I've discovered that working with these IGBT or MOSFET dimmers, it's a bit difficult to scale them. It's much simpler to scale the Triac type dimmers, which you can basically put in a line and have them all controlled by the same microcontroller and the same power supply. But this is a little bit more tricky due to the fact that you need to isolate these two circuits entirely, the ground, because the ground to drive these MOSFETs is in the center point, and the center point here. And if you have a common ground, because you've got a common controller, then the problem is that you actually connect the AC on both ones to each other. So if you have one off, the other one will drive the other side. So that doesn't work. You have to have it totally isolated, which makes it a little bit more complicated to make a multi-channel version of the trailing edge dimmer using these IGBTs. However, this is an isolated one that I've been testing and just trying out just to see how things work. And it's controlled by this WeMOS T1 Mini connected to Home Assistant. And we've got the two channels, 8 downlights on each channel. So we'll just turn it on now and try it out. One's in leading edge mode and one's in trailing edge mode. So we see that on the oscilloscope, we've got the leading edge dimming happening. And you'll find that this one is actually overcurrent due to this little IC here. So if we increase it, we'll see it just cut out. Once we get to about 50%. So that's the overcurrent that actually just cut that out then. Now, if we check out the other side, we'll just check the other one out. So this one we'll put it up to 100%. So we've got the full wave there on the oscilloscope. And we can dim that down. Now you notice that works quite well. That's this side here. And it's fine, except I'm getting interference when we turn the other dimmer on. So when we turn the other dimmer on, we get interference. So I'm not sure where that interference comes from yet. You can only have one channel on at a time. And if you have two channels on, you get interference. So I believe that's probably coming through this section here somewhere rather than over here. But I'm pretty sure I know what I can do about that. Anyway, that's the prototype, testing purposes only. Let's move on and check out the last dimmer we've got. And that is not an AC cut phase dimmer. So we've got something a bit different we're going to check out. All right, the second last type of dimmer we're going to look at is a DALI dimmer. So I've touched on this in videos in the past, and it's an excellent way to control light fittings. It doesn't manipulate the phase angle like all the other ones we've been looking at. It digitally controls the driver so it puts out the right amount of power. So it's much, you don't get any flicker at all basically. It's very, very good quality light that you'll get out of it. I've got a 24 volt driver here, 60 watt to connect up to this LED strip I've got, which is a 24 volt strip. And we're going to be able to control this light with DALI and this driver. Now, a DALI system just requires three things: a driver, a master, which we have here, and a power supply, which is built into this master. It has a power supply built in. Now, if you want to play around with DALI and perhaps do some programming with it, this is really great, this little master. It's not expensive. I think it was 100 euros. And it has a whole lot of open source Python modules that you can use to control it. So possibly, maybe you could integrate this into Home Assistant if you're good at programming. I'm not that great at programming yet, but maybe I'd hope to give it a go one day because it would be pretty handy. And of course, you can connect these drivers up to all sorts of lights. So just downlights like this. Of course, this one will need a constant current as opposed to constant voltage. And you simply need to match up the light fitting that you have. And if you look at this one here, it'll have on the data sheet somewhere how much constant current it needs. So this particular one is 13 watts and it needs 300 milliamps. So you could find a 300 milliamp driver and 13 watts, or it can be less if you want, and that will drive this downlight. So you just can match it up and you can add it to a DALI network. So let's try it out. Let's give it a go. We're going to use the console and Windows to control it. Okay, so I've got my driver and my DALI master connected up to this LED strip just here, and that's all connected to my Windows computer. And we've got that here, the DALI 2 controller panel. Now, this is just the easiest way just to demonstrate it and try it out. We can send commands on the DALI network using this little program here. You can also use, like I said before, Python modules to control it. But what we can do is just turn things off and on like so. So we can do a direct power level command. So our driver is address 0, and you can have up to 128 addresses on DALI 2. And we'll set the level to the maximum, which is 254. And we'll send that command, and we see our lights turn on full power. If we want to turn it down to 100, we can do like so, and it dims it right down really low. And we can also do up and down commands. So if you want to increase it, you can increase it like so. Or a down command. And that's just sending out commands to that address there. There's a whole lot more commands you can do. You can assign this driver here, this driver to a group, or you can do a broadcast command which affects everything on the DALI network. So you can turn everything up and down or set everything to a certain level. And there's quite a lot you can do with DALI. It's actually a very established and good quality system to use to control light fittings, and it's obviously used mainly in commercial buildings at the moment. But that's DALI. It'd be pretty cool if we could somehow integrate that into Home Assistant, and it seems like that little DALI master I showed you is the best one to use if you wanted to try it out and have a play with it. Okay, we're just going to move on to the last one, and that is just the plain old rotary dimmer. And of course, if you're just here and you're like looking for an ordinary dimmer, I have my recommended plain old rotary dimmer, which I use all the time. And if you don't want home automation connected at all, and you just want a good dimmer, this is the one that I would recommend. It's a Diginet dimmer.
this is the particular brand and type I would recommend. The only reason I wouldn't use this dimmer is if it doesn't match your decor. I think it has a green little LED light that turns on inside, so it has a green ring that glows around the knob here, and you might have dimmers already and it won't match. And unfortunately, because of the way the knob attaches, you can't swap it over to match existing Clipsal dimmers, so that's the only downside, but it is an excellent dimmer. It works really well. And we'll just check this one out now on the oscilloscope as well and see how that works too. And I believe this is designed for LEDs, but it is a universal dimmer, so it would probably change mode from leading edge to trailing edge as appropriate. But yeah, it's really good dimmer, this one here.
Okay, so now we've got the ordinary rotary dimmer connected up, so there's no smarts at all. And we're going to just try it out. So we've got it at full power now, and we can see that at full power, because it's a 2-wire dimmer, that we see that it can't go to the full 100% power output. And this dimmer is currently running in trailing edge dimming mode. So it's obviously determined that that is the best mode to run in for this particular light fitting. And you see as we just dim it down, it works pretty much the same as the other dimmers that we've been working with. This one will go down very low, and it has excellent control over the lights, which is why I recommend it if you just want an ordinary dimmer. So that's the ordinary plain dimmer.
And of course we have to finish with the Shelly dimmer, which I am still going to say is the best dimmer that you can get if you want to add it to your home automation system. Nothing beats it yet, and it's a great little dimmer for a pretty good price. So we've got all 160 watts worth of lighting connected up to it now, which it's able to handle perfectly. So that's this little guy down just here, dimming all 16 downlights. I'd like to thank everyone for watching and for checking out the video. If you want to see more videos about home automation and electrical installations, please subscribe. I'll catch you next time. Bye.